Hi everyone, we're going to take a look at a common data structure called dictionaries. And this terminology is specific to Python. In other programming languages, we encounter this same kind of data structure, but it's usually called an object. In Python, we tend to refer to anything as an object, any entity or variable. Anything that exists in Python is called an object, but dictionaries have a very specific definition. And the structure of a dictionary is like this right here. So we give the dictionary a name, we assign it to this collection of pairs, and we use curly brackets to specify the dictionary. And within the dictionary, we have pairs of keys and values, and the keys and values are separated by a colon, and then the key value pairs are separated by a comma. Okay, so here's an example of some data that might make sense to organize as a dictionary. Some stock prices. So we may have pairs where the key is the symbol for the stock, and then the value is some sort of numerical measure associated with that stock, market cap, some kind of price or percent change or something like that. So it might make sense to organize the data in this way. So we'll go through the processes involved in accessing values in this kind of data structure. Okay, so to access the value associated with any key, what we do is we type the name of the dictionary, and then in brackets we specify the key. We can specify the key by name. So let's just see what happens here. So when I do this, I'm looking at Apple and I'm accessing the value associated with Apple. Another way to do that is with get. Okay, and I believe they both return the same data type, but let's just see what we get here with this. They should both be giving us a string. Let's check that. Oh no, that's a float, obviously. Okay, yes, because I'm getting the value. My mistake, right? Type. This should also be a float. Let's make sure that's the case. Okay, good. So the data type of the value is preserved. All right, so every data structure in Python tends to have its sort of methods that are unique to that type of data structure. So when we work with dictionaries, the way to add a value to the dictionary is by specifying the key. So here we're entering a new key, new symbol, GS, Goldman Sachs, and then we set that value, that key, equal to its value. Okay, so we can then print the dictionary and see that we have now added Goldman Sachs, this key value pair. Okay, and then this is just a repetition, trying it again, right? So that's how we add values to a dictionary. That's how we add pairs of keys and values to a dictionary. We can also remove, and we do this using the delete method when we're working with dictionaries, and you'll find that there are some other methods we can use as well. So let's see what happens when we do this, specify the key that we want to remove. So it doesn't just remove the key, but it removes the key value pair. Okay, here are some other methods we can use with dictionaries. We can get all of the keys, and I might be curious to see what is the type. What type of data is returned when we do this. So I'm going to check the type. Okay, so it has its own specific type. It's dict keys, and that only applies to dictionaries. We don't see this data type in any other circumstances. Okay. So here is another method we can use, and just like we saw with the keys, the data type is also going to be dict values. So let me prove that to you. Okay, dict values, a data type only found in dictionaries. So finally, here are some things we might end up doing when working with dictionaries. We might find ourselves using a for loop to print, say, or perform some kind of operation on all of the keys in a dictionary or all of the values in a dictionary. And the easiest way to see the behavior of a loop like this is to just try printing each item in the dictionary. So when I do for I in M market caps and then print I, notice that what I get is all of the keys. Okay, if I want all of the values, I do something slightly different, right? So for J in market caps, I'm going to print market caps and index by J, and that's how I access the values. Okay, so here they are, right? All the values. All right, and then finally, there is another method that we can use to get all of the items in the dictionary. And this returns the key value pairs, and this is what they look like, and we're just printing them at this point, but I'm going to show you. I want to look at the data type. Okay, so if I look at the type for each of those items, I can see that the type for I is string because that's giving me the keys, and those are specified as strings. The type for J corresponds to the values, so the data type for each of those is a float. And here we see that, okay, string, float, string, float. All right, I'm gonna modify this slightly. And instead of specifying I and J, I wanna rerun the whole thing with just item. Okay. So when I modify this method and only specify one variable to iterate over, I'd like you to notice how the output is different. Okay, so let's scroll all the way down to the output of this last command that I've done and notice what we get. Okay, so the output is pairs where the key and the value are separated by a comma, and this is a particular data type called a tuple. Maybe it's called a tuple, but more commonly I hear the term tuple. Tuple is a data type that's data enclosed in parentheses, and then the values are separated by commas. And we do encounter this data type at times when we're extracting web data, especially data from HTML. So we'll hear more about tuples in our next lesson, but just notice that particular data type at this point. So lastly, here are a couple, here's one more method that might be useful for us. And this is a way that we can check if an item is in a collection. We could say if Goog is in MKT caps, the dictionary, I'm going to print a statement. Okay, so that could be useful at some point. And here's an exercise for you to try using some of the methods that we just went over.